I don't want to waste any time with this incredible group of people that we've assembled. So we're going to get started as people continue to join us in the Zoom room. So my name is Sam Myers. I'm the director of the Planetary Health Alliance and a principal research scientist here at the School of Public Health. This is our sixth talk or series of talks in the Planetary Health Colloquium series that we've been running over the course of this year. It's been co-sponsored by 4 departments here at the School of Public Health, as well as the Harvard Center for the Environment and the Harvard Global Health Institute, as well as the European Environment and Sustainable Development Advisory Councils. And so we have a broad community around the world. These sessions are being recorded, and we'll put a link in the chat for the past sessions, as well as where you can find the recording of this session if you want to share it with anybody. Today's talk is actually going to wrap up a series of presentations that have been going sort of systematically across each dimension of human health and how infectious disease, nutrition, non-communicable diseases, mental health, and now sort of displacement and conflict are being affected by global environmental change. And the final 2 sessions starting next month will be really pivoting to look at how planetary health as a framework can be useful in really catalyzing change both in the private sector and also in the public policy domain. I'll have a little bit more about that at the very end of this session. So today, we're really lucky to have 3 world-class research scientists who are going to be taking us through sort of stitching together a narrative based on extraordinary research, looking first at the impacts of climate on agriculture and crop yields, and then on how you can see signals between biophysical changes and climate change and migration from agricultural communities as people have to move. And then ultimately, what do we know about how global environmental change is driving displacement and insecurity and conflict? And so we'll start with John Proctor. John is a postdoc fellow working jointly at the Harvard Data Science Initiative and the Center for the Environment here at Harvard. He's an environmental economist with a background in agronomy, climate science, remote sensing, and machine learning. And he develops and applies new methods to estimate human impacts on climate and in turn climate change impacts on crop growth, among many other things. After John, we'll hear from Hélène Benveniste, who is also a postdoctoral fellow here at the Center for the Environment. She's also based at the Kennedy School and has really strong interest in the consequences of climate change on human migration and the sort of potential role of environmental policy to address those vulnerabilities. And then finally, our sort of cleanup hitter will be Cullen Hendricks. Cullen is a professor at the Korbel School at the University of Denver. He's a non-resident senior fellow at the Peterson Institute for International Economics. He has many other impressive appointments and is a leading expert on the economic and security implications of climate change, where he's consulted for several different organizations, including the Department of Defense. So he'll provide a slightly broader perspective. So with no further ado, let's jump in and let John get started with his research. Thanks so much.
Awesome, thank you. Can you all hear me? Sweet. So welcome and thank you all so much to the organizers for organizing this and for you all for being here. The study of climate impacts on agriculture, food security, migration, and human well-being broadly is both an area of great urgency and opportunity. The urgency in part stems from the fact that despite decreases in global undernourishment over the past few decades, we've recently seen a concerning increase in the prevalence and number of undernourished people globally over the past 5 years. This upward trend is especially concerning in regions of the world that are the most food insecure, such as Latin America and the Caribbean, and especially Africa, where in 2020, as much as a quarter of the population went a day without eating due to a lack of inadequate food supply. Now, it's thought that climate change is a key contributing factor to this recent increase in food security, along with, of course, economic downturns, conflict, and the pandemic. But substantial uncertainty remains about how climate change has influenced and may increasingly influence food insecurity. While it's well understood that warming has caused and will increasingly lead to reductions in global agricultural productivity, the full impact of climate change is uncertain due to other key factors, especially changes in water supply. The uncertain influence of water supply on agricultural productivity is in part due to the differing ways in which water supply is represented in statistical crop models. So empirical studies tend to represent water supply, i.e. the amount of moisture available to the roots of the plants, using precipitation, and generally find only a minor influence of water supply on crop yields, often leading to the omission of water supply effects from main lines of analysis altogether. A minor role of water supply, however, is at odds with the plant physiological literature and stated causes of damage, such as US insurance claims, both of which indicate a larger role of water. Our hypothesis in this work is that more accurate specification of crop water supply using soil moisture and temperature stress jointly will reveal a larger importance of water for global crop productivity. The main contribution of this work is to provide the first empirical estimates of how soil moisture and temperature stress jointly influence global crop yields. This reveals for the first time a dominant role of water supply in determining global agricultural productivity. These findings build on recent studies of US maize, which have similarly indicated an important role of water supply. So what are the mechanisms that we're considering here? So for a plant, we want to think about water supply, water demand, and temperature. Water supply is primarily determined by root zone soil moisture, so how many water molecules there are around the roots of the plant. Water demand is primarily determined by vapor pressure deficit, or how hungry the atmosphere is for water, which is closely related to maximum temperature. Under low water supply or high water demand, plants may close their stomata, their little breathing holes, in order to conserve water, but thereby reduce carbon uptake, photosynthetic rates, and yield. Low water supply can also encourage root growth at the cost of edible yield, and in severe cases lead to cavitation, embolism, and crop mortality. On the other hand, excessive water can also cause problems such as root rot. Hot and cold temperatures can also directly influence yields. Too cold temperatures can kind of slow crop development, and too hot temperatures can, for example, damage key reproductive parts of the plants, such as flowering. The importance of jointly accounting for both temperature and soil moisture to understand these effects is demonstrated by their strong correlation at the daily level over cropped areas over the growing season, shown here where dark reds indicate a strong negative correlation between water supply and temperature. The correlation between soil moisture and precipitation, however, is relatively weak at the daily level and still imperfect at the seasonal level due to heterogeneous runoff, infiltration, and evaporation. This indicates that precipitation is an imperfect proxy for soil moisture and thus for crop water supply. This is important because the strong correlation between temperature and soil moisture indicates that imperfect measures of crop water supply may bias estimates of temperature stress on yields in a classic omitted variables bias sense. So with this as motivation, we're going to jointly analyze how soil moisture and air temperature influence the yields of four staple crops globally. In this formulation, soil moisture represents water supply, and temperature is going to capture the effects of both water demand and direct heat effects. And we're going to use a kind of standard panel fixed effects regression strategy here. We're regressing log yields in a given country and year on a nonlinear function of daily temperature and soil moisture. We then compare this temperature and soil moisture model to a model that is similarly structured using temperature and precipitation. So to measure water supply, we're going to use satellite observations of daily surface soil moisture. And we complement these measures of water supply using station-based measurements of daily maximum temperature and precipitation from the Climate Prediction Center. We combine this environmental data over cropped areas during the growing season with annual national measures of maize, soybean, sorghum, and millet yields from the Food and Agriculture Organization of the UN. Putting this all together, this brings us to three main results. The first is that soil moisture improves the representation of crop water supply in empirical crop models relative to precipitation. Specifically, we find that model fit increases for all 4 crops in the temperature and soil moisture model relative to the temperature and precipitation model by between 28 and over 100%. The second main result is that this improved representation of crop water supply leads to better separation of water supply stress and temperature stress. This in turn has 3 implications. The first is that this better separation reveals a dominant role of water supply in determining year-to-year variability in agricultural productivity. We find that soil moisture contributes more than temperature to the predicted year-to-year variability in yield than in yield anomalies for maize, soybeans, and sorghum, though less for millet. And importantly, both temperature and water supply are important for all 4 crops. The second implication of this separation is that it removes damages due to dry soils from the estimated influence of extreme heat. So here we have on the x-axis daily temperature on the left and soil moisture on the right. And on the y-axis, we have the influence on yield of changing temperature from 20 degrees to a given value and changing soil moisture from 0.25 centimeters per centimeters cubed to a given value for maize on the top and soybeans on the bottom. The solid line shows the estimated temperature response function accounting for soil moisture, and the dashed lines shows the response accounting for precipitation. We see that increasing temperature, as we would expect, benefits yields up to a point after which future warming is damaging. What's interesting here is that we also see that damages from extreme heat are exaggerated in the temperature and precipitation model in dashed relative to the temperature and soil moisture model, again in solid. Damages are moderated in the temperature and soil moisture model because soil moisture accounts for the water supply stress that otherwise is baked into the temperature response. Turning to soil moisture, we see a positive influence of soil moisture along most of the support with diminishing marginal returns to soil moisture in wet conditions. These patterns are generally similar for sorghum and millet. The final implication of this improved separation of water supply stress and temperature stress is that it demonstrates that some of the benefits of irrigation in the literature attributed to mitigation of heat stress instead result from attenuation of water supply stress. So putting this all together, our third result is that improved representation of water supply and better separation of water supply and heat stress lead to more accurate projections of the influence of climate change on global agricultural productivity. So to see this, we apply the temperature and soil moisture statistical models trained earlier to CMIP6 projections of climate change to project future changes in agricultural productivity. From present day to the end of the 21st century, we see that temperatures are projected to increase by just over 4 degrees over global croplands on average. In turn, growing season soil moisture decreases by about 1 to 2% of historical variability, with substantial regional heterogeneity. This warming and drying leads to decreased global average crop yields. In the blue, we have projections of climate change damages from the temperature and precipitation model, and in orange, we have projected damages from the temperature and soil moisture model. Stars show the impact in each CMIP6 model, and the circles show the average effect across CMIP6 models. We see that projected damages in the temperature and precipitation model are overestimated by 30 to 300% relative to the temperature and soil moisture model. Why does this happen? The reason is that projected warming from climate change is actually associated with less drying than would be expected based on observed synoptic correlations. So put another way, historically, a 4 degree hotter growing season is on average 0.5 centimeters per centimeters cubed drier, which is an order of magnitude more drying than the corresponding drying projected with climate change. Thus, models that confuse temperature and water stress historically implicitly overproject future damages from drying soils. And so an important implication from this and this paper generally is that it's really necessary to capture the direct drivers of yields, i.e. water supply and temperature, rather than proxies such as precipitation. And that now we have the data to do that. The last result here is that breaking down the projected damages from temperature and soil moisture into its component parts, we see that the vast majority of projected damages are due to warming, shown in red, with drying, shown in turquoise, playing a more minor role. And this indicates that a key reason to improve representations of water supply in empirical crop models is to get the influence of changes in temperature on yields correct. I'll conclude here by noting that a key limitation of this study and kind of the field broadly is that climate models have a difficult time simulating soil moisture. We see here that CMIP6 models simulate current growing season distributions of temperature on the left in red quite well relative to observed values in black, but have a tough time simulating soil moisture distributions on the right, shown in blue. This suggests that improvements in climate model representations of soil moisture are needed to better constrain our understanding of how climate change might influence global agricultural productivity. Projections of limited damages, as we see here, from changes in soil moisture with climate change may change with such improvements. It also suggests that projections of yields may be actually more uncertain than previously anticipated due to the difficulty of understanding changes in soil moisture. I'll conclude by noting that in addition to improving projections of yields, improved representations of water supply and temperature stress may also improve our understanding of how other key agronomically dependent determinants of welfare, such as conflict or migration, respond to changes in climate. And with that, I'll pass it over to Helen.
Thanks, Jeff. This is great. Let me share my screen unless Sam, you want to say a few words now. Should I go ahead? I'll go ahead.
Go ahead,
Okay.
Ellen.
Great. So, well, I thought what would make sense today would be to start by kind of briefly giving an overview of what is known about the relationships between climate change and mobility responses. I think it's pretty timely discussion given the publication on Monday of this IPCC report on impacts, adaptation, and vulnerability, where migration is featured at length. And then I'll talk briefly about a project that I'm currently working on now at Harvard, actually in collaboration with John, who you just heard, as well as with Peter Hivers. And so I want to start here by saying just a few words about how the relationship between climate change and migration tends to be talked about in the media and in the general public. These are just a few newspaper articles that have come out in recent years on this topic. And as you can see, they kind of all focus on one specific type of migration, which is international migration towards Western countries. That's often how it seems that the general debate on this relationship between climate change and migration is framed. However, this mobility response really is just one among many outcomes that we can see. And when I talk about mobility outcomes, I very much include immobility as well. You might wonder why. Well, that's because both migration and immobility really are two sides of the same coin. They're both not always the result of an actual desire, either to move or to stay. They can be a choice, or they can be more of an involuntary consequence of a given context. Now, while immobility can absolutely be a choice, we also know that resource constraints can limit the ability to migrate. And that's because migration, and in particular international migration, requires resources. You probably know whether economic or social or health related, really those who move are those who are able to do so. And this is true for any type of migration. But now when you start thinking about the consequences of climate change on those various mobility outcomes, well, those consequences actually can be quite complex. And depending on the context, climate change can either induce an increase in mobility or an increase in immobility, with varying degrees of agency in the mobility outcome. And here I'm trying to illustrate this point with those different pictures. If you start from the picture on the left, that illustrates climate-related displacement, that's often the one type of outcome that people think about when they think about climate migration. But as you can see, there are several other types. If you look at the picture on the top right, that's meant to illustrate the fact that migration is already a widely used adaptation strategy to impacts on climate change. So perhaps with increased climate change, we will see an increase in the use of migration as an adaptation solution. Now, the two pictures on the bottom illustrate cases of immobility. The one on the bottom right is probably something you've thought about already. It illustrates cases where people are able to adapt where they are to the impacts of climate change they are going through, and so that they don't have to move if they don't want to. Now, the picture on the bottom left also illustrates the fact that climate change is expected to deplete resources, and in particular, in some of the most deprived areas. Again, resources are needed to migrate. And so with increased climate change, we might also see a decrease in the number of people who are just able to move in the first place. Now, those various mobility outcomes are going to lead to various levels of risks for the populations involved. And here, when I talk about risk, I very much use the definition that is used by the IPCC of risk being a conjunction of hazards, exposure, and vulnerability. So typically, the first response to these types of risk tends to start by adaptation in situ, so where people are. If that adaptation is successful, remember that was the bottom right picture in the previous slide. If that adaptation is successful, that leads to a decrease in risk. Then if the adaptation is not successful, however, that is when you start seeing mobility-based responses. Those mobility outcomes can lead to various effects on risk. If you're able to use migration as a successful adaptation strategy, you're able to decrease your level of risk. That was the picture on the top right in the previous slide. However, if you're, for instance, constrained to do climate-related displacement, that can lead to an increase in risk, or if you end up staying in an immobile position due to increased resource constraints, that can also increase risk. And so I think this framework really is helpful to think about all the multiple consequences of climate change on mobility outcomes, and perhaps more relevant, on the risk levels of the population. And if you want to read more about it, I would really encourage you to check out this report that came out on Monday, and in particular, the chapters 7, 8, and 16, which are the ones that deal with migration. And now this is kind of a conceptual framework, but now in practice, which one of these outcomes do we see happening more? Well, it depends a lot on the study that you're looking at. And here I'm featuring a meta-analysis that came out a couple of years ago, where the authors basically gathered all the quantified information that we have out there of the effect of environmental change on migration. So here you have the effect on within country migration and on international migration. Basically on each graph, each of these box plots here is for one study. And the main point you want to look at here is those vertical zero lines here. If the values are to the right of that line, it means that environmental change is inducing more outmigration, and to the left of the line, it means environmental change is inducing less outmigration. So the main point I want you to take away from this graph is that we see a lot of heterogeneity, a lot of variation in the mobility outcomes across the literature. And it basically depends a lot on the context. But so what do we mean by that? What are the causes of these variations? Well, one of the explanations that is put forward in the literature relates to the level of income of the location where the migration is taking place. So often we tend to see an increase in outmigration in countries that are kind of more middle income, but we tend to see a decrease in outmigration in countries that are more lower income, kind of hinting again at this resource constraint that needs to be overcome in order to migrate. However, there isn't as much information as of yet on the effects, not just of the location level characteristics, but also the individual level characteristics. So really, who are the would-be migrants? And this is what we're trying to look into here right now. And it turns out to be a pretty important question because perhaps obviously not all types of migration involve the same people, which means they don't reflect the same realities on the ground, and so they don't reflect the same policy needs. And in order to illustrate this point, we're using here data from IPANS, which is a database that's managed by the University of Minnesota, where basically they gather all kinds of census data from many, many countries. And we end up having information on within country migration and international migration. But importantly, we also have access to information on individual characteristics of migrants, in particular in terms of age, gender, and education level. So when you plot that data here I'm plotting the outmigration rate for within country migration in blue and green international migration. And I'm plotting it for different demographic groups in terms of age categories, education level, and gender. What you see here is that the internal migrants and the international migrants have pretty different age profiles and education profiles. So it kind of sounds logical that the effects of climate-related stress and even climate change would be different across these different categories. And so that's what we're trying to test here. We're going to focus particularly on agricultural areas, which is where people tend to work in a sector that is particularly climate sensitive. In terms of climate data, we're going to be using exactly the data that John just discussed, that is daily maximum temperature and soil moisture averaged over each location's crops growing season. And what we're going to look into is how the anomalies in these variables are going to affect migration patterns. And we're particularly going to be looking at agricultural areas, which we select by using the share of employment in the agricultural sector. So this is work in progress, but let me show you a first pass here at results. I'm just simply plotting the effects of temperature anomalies on the left and soil moisture anomalies on the right on the outmigration rate. This is strictly for internal migration. What we find here is first we see a pretty distinct effect of climate anomalies on outmigration, but you might notice perhaps a bit of inconsistency between the effects of temperature and soil moisture, with hotter temperatures leading to a decrease in outmigration, while drier conditions leading to an increase in outmigration. However, when you start looking at this effect per demographic group, so here I'm showing per age category, you see first that for a given age group, there is much more consistency between the effect of temperature and soil moisture anomalies. But then more importantly, I would argue, you see first that across the different age group, you see different baseline outmigration rates, which is something that I had already shown in this bar graph a couple slides ago. But you also see that there is a different sensitivity to climate anomalies. The slopes here across the different curves are not the same. And in particular, what we tend to see is that the youngest people tend to migrate a bit less under climate stress, while the older people tend to migrate a little more. We tend to find similar results across education levels, also for internal migration. Here, let me note that we don't find much effects of climate anomalies on international migration in this data set. So just wrapping up very briefly, this is still ongoing work, but what these results tend to suggest to us is that the effects of climate-related stress and climate change on mobility are likely to be really heterogeneous, and importantly, heterogeneous across demographic characteristics of the migrant populations. And so if you think back to this framing that I mentioned at the beginning of climate migration often being talked about as mainly a matter of international migration towards Western countries, you start seeing some flaws in that framing. And that's important because policies that would be designed only for that one sole mobility outcome, while they might substantially underestimate the detrimental impacts of climate change on vulnerable populations across the whole range of mobility outcomes that are likely to take place. And let me say just a quick word to finish on the current institutional landscape that's relevant for this issue. At the international level, that includes the US Sustainable Development Goals, and in particular Goal 10, which includes migration, and Goal 13, which is about climate, as well as the UN Global Compact for Migration, which is this non-binding agreement that was signed in 2018, and the UN Framework Convention on Climate Change. At this point, none of these institutions actually, they only focus on mobility and displacement. They don't focus on mobility at all. And some of them actually just focus on international needs. So I'm really hoping that this will change in the future so as to really better reflect the very heterogeneous responses that we see in terms of mobility to climate change. And with that, I'm looking forward to Cullen's presentation. Thanks.
Terrific. Cullen, you're on.
Thank you very much. Can you see my screen now? Okay, perfect. It's wonderful to be with all of you today. I hope you don't mind if I sort of pitch my comments at a somewhat higher kind of level of abstraction. I'm doing that for a couple of reasons. One, because I'd like to talk a lot about kind of mechanisms and theoretical channels rather than particular empirical findings, which I'm happy to discuss in the Q&A. But also, frankly, I'm intimidated to show some of my newer research in the context of this just fantastically teched up and incredibly strong new cohort of researchers, of which John and Elaine are part. So I'm going to take my graybeard kind of status here and talk a little bit more about some of the policy implications of some of the findings that you've seen as they're reflected in the discussion of the impacts of climate change on migration and thereby social conflict. So hopefully that will be all right with everyone. Now, before I get started, I want to just note that in policy discussions, especially here in the United States, migration is increasingly being framed as a security issue. And if you want some evidence of that, you need look no further than the Biden administration's report that came out of the White House, right? This is not a security document coming out of the DoD, but it's a general document coming out of the White House on the impacts of climate change on migration. And indeed, the first topic that it discusses is geopolitical, with emphasis on the effects of climate change for declining rural livelihoods and migration from Central America, and its effects for the US southern border in particular. Now, I am going to talk about several mechanisms that are going to link climate-fueled kind of migration to conflict outcomes. But I want to, avoid giving the wrong impression here. I think it's really important that if you go away from this kind of talk and the series of presentations, understanding that at most times and in most places, migration is a positive and humane and adaptive strategy in response to climate change. That is, most of the time, it's not the flame that you see here under the kettle, right? That's actually the forcings that are operating through climate change. Rather, often, migration is the release valve, right? Migration is the thing that allows societies, and in particular, affected members of societies, to release the otherwise kinds of mounting economic and social pressures that would likely occur in the absence of the ability to use this kind of adaptive strategy. But that's not always the case. And so in the remainder of my talk, I'm going to spend a few minutes outlining kind of four sort of different kinds of pathways linking climate change to conflict via migration. This is based both on my own research, but my recent experience synthesizing some of this research as part of the IPCC process that resulted in the wonderful document that Hélène was speaking about earlier. So I'm going to start with the one that's probably most familiar to you, if you're following at all kind of the US debate over immigration from Central America. And that is a pattern that goes from tensions between recent arrivals, especially culturally distinct recent arrivals, and host or longer term residents in kind of a given area. And there is some kind of evidence to suggest that this is the case. I'll come to this map here in a moment. It is indeed the case that in many circumstances, new migrants do place temporary strains on local communities in terms of resource needs. And they may create, some longer term competition for jobs and suppress wages. Although the kind of microeconomic analysis and city and county level analysis in the United States would seem to suggest that under most circumstances, this in-migration is actually a net economic positive. And we see this kind of discourse and these kinds of conflicts occurring across the United States and Europe. But where we see them becoming the most severe and the most violent tends to be in rural societies, where land is a very precious natural resource, and it's linked to most livelihoods very directly. And in particular, in those areas where available arable land, so land that can be used to plant crops or to graze animals, is in decline due to increasing desertification. So this map you see here is a map of conflict hotspots in Nigeria over the last several years. Now, one of these conflicts you're probably familiar with from reporting, which is the conflict that the Nigerian government is having with the Boko Haram rebel movement that is active in northeastern Nigeria and Western Cameroon. Now, and there are actually conflict linkages between that conflict, conflict impacts on that conflict. I'm not going to talk about those. What you're probably less familiar with is actually, in some senses, a larger conflict. Excuse me, my map is not agreeing with me here, so I'll just kind of wing it here. What you're probably less familiar with is actually the conflict that's occurring in Nigeria's middle belt. This is this area right here. If you can see my mouse over here, where you see a higher density of these kind of teal sort of hotspot markers. And what those are indicating is they're indicating instances of communal conflict or ethnic militia conflict. Now that's primarily between the predominantly Muslim recent arrivals, the Fulani, who have historically led kind of pastoral livelihoods around animal herding in northern Nigeria. And those livelihoods are being increasingly challenged by climate change and increasing aridity in northern Nigeria, which is forcing those populations and the herds on which their livelihoods depend further south into areas that are already inhabited by sedentary farmers. And this is creating real significant tensions. In fact, those tensions have gotten so high that as of the last few years, the conflict in the Middle Belt has actually claimed more lives and displaced more people than the conflict that you're hearing about more in the news, which would be the conflict with Boko Haram. All right. So the second pathway I'd like to talk about is related to critical minerals and mitigation related in migration. Now, this occurs when you have kind of recent arrivals, both people and firms, who are seeking to make profits by feeding the impending boom in renewable energy that will be a necessary part of mitigating future climate change. So this chart here from the International Energy Agency indicates that demand for some critical minerals key to creating renewable energy systems like lithium, graphite, cobalt, nickel, et cetera, will rise by a factor, or need to rise by a factor of 20 relative to current production levels in order to meet net zero carbon emissions kinds of targets. Now that is going to mean more exploration and mining in more locations. Now, for geological reasons, many of these kind of critical minerals are found in mountainous, somewhat sparsely populated areas. It's one of the reasons why my home state of Colorado is home to both world-class skiing, but also hundreds, if not thousands, of mines. All right. For historical and political reasons, these regions are often inhabited by marginalized people who are skeptical, if not outright hostile toward national governments, which are typically dominated by other types of ethnic groups and which have been the perpetrators of the marginalization and delegitimization of these kind of indigenous communities for decades, if not centuries at this point. So governments in these areas have very little presence and very little baseline legitimacy in the form of, say, provision of public services. All right, so you can think about this in terms of the indigenous populations that inhabit the highlands of the Andes, or minority ethnic groups in Myanmar in areas which are rich in antimony. Now, these mining projects can be very highly lucrative for mining companies, and they are necessary for fueling the critical mineral transition. But they also impose very specific kinds of environmental costs and harms on local communities. They use lots of water, they contaminate existing groundwater supplies, and they often displace communities because the mine has to be put somewhere. And they tend to employ kind of sort of foreign, international, or not at least non-local workforces that create grievances over a lack of the shared economic opportunity among locals. For this reason, these projects are often opposed by local communities, such as the protest you see here against the Tia Maria mining project in Arequipa, Peru. And if extractive firms, are not careful about achieving a social license to operate, about interacting with local communities in order to come to an equitable distribution of the benefits of these projects, we should not be surprised if the impending mining boom also becomes a spark for conflict. Now, the third mechanism is via the effects of increasingly frequent natural disasters and the effects that they will have on government capacity and legitimacy, which are two key factors for the maintenance and promotion of political stability. Now, reasonable people do not hold the government responsible for droughts or cyclonic storms, flash floods, or other rapid onset kinds of natural disasters that are becoming increasingly frequent and severe due to climate change. Even insurance companies, for whom assigning blame, right, is key to protecting the bottom line, terms these events kind of acts of God for which no one can be held accountable. People do, however, hold governments accountable for their preparations for and responses to disasters. And you need look no further than the Syrian Civil War to see that in action. Now, as this chart on the left shows, from 2006 to 2011, Syria experienced one of the worst long-term droughts in the history of the Fertile Crescent, with climate scientists calling it the worst in instrumental record. Now, in agriculturally dependent regions like Hasakeh in the Northeast, saw 75% of crops fail and herders lose 85% of their livestock. So the massive economic and social consequences. These losses left 1 to 1.3 million Syrians food insecure and made rural life just frankly unsustainable. Fleeing the drought-imposed hardship, more than 1.5 million people, mostly agricultural workers and family farmers, moved from rural areas to cities, slums, and camps in and around Syria's major cities. Now, this rapid mass migration put significant strain on these urban centers, especially as food prices were skyrocketing across the Middle East and North Africa in the context of the Arab Spring. And taking cues from Arab Spring protesters in other countries, many people were brought into the streets, right, displaced people, but also kind of rank and file urban Syrians alike, in protesting the al-Assad regime, demanding the release of political prisoners and sort of political and economic liberalization and greater imposition of social safety nets. These demonstrations began peacefully, but escalated to violent clashes as security forces responded in a heavy-handed manner. And kind of the rest is sort of, as they say, history, right? Up until recent events, perhaps kind of the most enduring and damaging armed conflict of the 21st century. Now, it would be wrong to say that the Syrian Civil War is about climate change. I want to be very clear about that. The people fighting and dying there are not fighting over climate change, but rather longstanding issues like authoritarian rule, lack of respect for human rights, and exclusionary kind of patronage networks. But it was, in fact, the drought that cast into stark relief the regime's inability to meet the basic needs of its citizens. Now, climate change more generally is going to challenge many governments to respond to natural disasters and increasing pressure on social and political and economic systems. And the quality of these responses is going to have a huge impact on whether those governments are perceived as legitimate or not. And weak state institutions and a lack of popular legitimacy mixed with hardship in the wake of the natural disaster are a recipe for violent extremism and conflict. And I'll try to be brief in discussing this final mechanism. I'd like to talk about rural to urban migration, which Hélène discussed, I think, extensively in her comments, and increasing dependence on volatile global markets for meeting basic needs. When we talk about issues like climate change, especially its effect for a place like Africa, our thoughts are almost often dominated by images of small plot farmers tending to fields and children. Indeed, as this image shows, right, often at the same time. And many of these farmers are women, and many are already food insecure or relatively close to it. This mental image kind of conjures a specific set of challenges related to agricultural production and livelihoods and marketing that are, of course, all affected by climate change. But that's not the only face of food security related challenges moving forward. This is a life that many people lead in Africa and will continue to lead in the future. But the reality of food and water related challenges under climate change is changing as the region urbanizes at rates we haven't seen since Latin America in the 1960s. Now, this urbanization is fueling economic growth and a lot of dynamism, particularly in the service sectors of these kinds of economies, but it's also making those urbanites much more dependent on the vagaries of global commodity markets for meeting their food needs. All right. And those commodity markets themselves are becoming more expensive and more volatile as a result of the increasing dependence on a relatively smaller number of countries, which are experiencing greater environmental variability and greater variability in the yields of their crops, which is what John was talking about earlier, as a result of climate change. And when people are not having those needs met, they're likely to show up in the streets to protest about it. You can't quite see it here, but the hashtag here on the sign at this protest for the ouster of Jacob Zuma in South Africa reads, "Food prices matter." Right? Climate change is driving increasing urbanization and increasing volatility and high prices in global markets. And prices are already at record highs. So we can expect to see also political instability of this nature. So in sum, I've talked about these four major pathways. There are others, hopefully we can get to in the Q&A. And thank you for your time today. And in spite of all I've said, I want you to please remember that migration is not the flame that's pressurizing societies. That's climate change. In most cases, it's the release valve. Thank you.
Fantastic. Well, Cullen and Hélène and John, thank you so much for those great presentations, really fantastic. And I just want to take 1 minute of prerogative to reflect on these three presentations, because I think they all have something in common. And I think it's a really important theme as we kind of wrap up this sort of academic research scholarship side of this whole colloquium and move to thinking about planetary health in practice in the private sector and policy. And what that is the incredible importance of exactly this kind of work of scholarship. And I think that our community in the planetary health field and movement, because it's a field built in urgency, all of our hair is on fire. We're trying to address these global challenges with rapidity, and we don't have a lot of time. And there's a tendency to become somewhat impatient with scholarship. We know enough, we need to act, you hear all the time. And I think what's amazing about these three presentations is that they make it very, very clear that we actually don't know enough, and that in fact, these issues are complex and they're nuanced. So, John talking about how there have been very, very strong correlations between soil moisture and temperature historically. But if we try to project those into the future and say, well, because temperature is going to go up, soil moisture is going to go down, and we're going to have these major crop failures, that may actually be inaccurate. And so the models that we're using to predict crop failures into the future may really need some significant revisions. Well, that's an incredibly important insight for policymakers, and it shouldn't be ignored. Hélène talking about how, migration is an incredibly complex topic, and it depends on who you're talking about, what their sort of socio-demographic status is, whether you're talking about trapped populations not moving or, resource-rich populations being able to move, and those relationships matter. And so when you're making policy, you need to be thinking about which kinds of migration are you addressing and for which people. And Cullen's point that even migration itself falls into multiple different types and drivers. That yes, climate change drives people out, but the entire sort of great transition economy that we're calling for in the planetary health community to rethink food systems, energy systems, built environment, actually changes the externalities of markets and changes the value of certain kinds of commodities, and may drive all kinds of shifts in people's movements that are really important for us to think about from a policy standpoint. And there's a lot of other nuance there. So I think this is precisely why really vibrant research communities are so important to the field of planetary health, and why government should be funding planetary health research, and why universities should be supporting it. So thank you for those amazing talks. We have a question, and before I get to that, I want to, since I've seen Peter Hybers on the screen, if you're still here, I want to put you on the spot, Peter, if you're willing, because you're one person who touches on all of this work. You've been advising John and Hélène. You've worked in Washington thinking about climate change and security under the Obama administration. And I just wonder if you had a sort of couple-minute reflection on what you've been hearing and the complexity of all these issues before we move to the questions. So I just want to give you the floor for a minute.
Well, thanks, Sam. I appreciate you guys bringing this topic to the fore. What I guess I would just dwell a little bit on the incredible complexity that we're dealing with here. If we start with what John was talking about, with just the kind of physiological complexity of what actually determines agricultural outcomes, and then we move on to what Aline was kind of eloquently pointing out, that the consequences of food insecurity have these kind of multifaceted implications for people being able to move or not move. And then we move on to kind of a much broader kind of set of socio-political contexts. And what I would, that Colin, I appreciate the broad overview you gave. What I really think we need to do going forward is to start to really figure out, how do we link all the way from the physical understanding of how our environment influences our well-being to the sociological outcomes that are important. And what you've seen here today is, a strengthening of a couple of those linkages. This is a massive kind of undertaking of science, sociology, psychology, political science, and figuring out how to merge across all these different fields is something that's really going to take some time, a lot of work, a lot of effort, but there's a lot of exciting opportunities. And you've seen a few of those directions here today. So it's just been nice to be able to be a little bit of kind of watching these come together. It's been fantastic. So thank you.
Awesome. Thank you, Peter. All right. So a plea from scholars for the time and resources to actually really work out some of these relationships in all of their glorious complexity. And to counter that is a question from Chuck Woolery to Cullen, but I think to any of you, that at some level, he says all of these connections were clarified in the 1980 Bipartisan Presidential Commission on World Hunger. And it concluded that unless we put an end to hunger by 2000 in the context of national security, our world would experience increasing conflict overall. So why haven't we heeded the warnings of these uncontested studies and commissions? So this is the, at some level, we've known that these are very destabilizing forces. We haven't understood all the nuance, but we've understood that this is a big problem for a long time. From the policy standpoint, and particularly for Cullen and Hélène, who have strong policy interests, what would you say to that question? Why is the science and the policy somehow, the science somehow disconnected from action on policy?
No, that's a fantastic question. And I think that a lot of us who are working in the security space, but also beyond that, feel a lot like we're sort of the Cassandras of the national security discussions, because we're kind of doomed to see what's coming down the pike, but no one seems to be able to act on it. And I think that there are kind of two interrelated reasons for that. One of them has to do with the complexity of the ways in which climate change affects kind of security kinds of outcomes. And the timescales on which it tends to operate, right? I think of it less as kind of the decisive blow in most instances, and more like death by 1,000 kind of cuts, all of which are equally lethal if we add up all of these different types of effects operating through a variety of mechanisms, the ones we've discussed today, but also others. They can be just as lethal, but it's hard to catalyze, I think, kind of political mobilization and support around addressing those kinds of complex issues. And that's related to the problem that Morgan Bazillion and I have talked about, which is that, you know, climate change in a lot of its instances is a fundamentally kind of actorless threat. And what that means is that we have a national security architecture that's built to kind of identify, deter, or neutralize other armed actors, be they state-based like North Korea, or non-state actors like Boko Haram, right? And so if over the last, say, 2 years, a country like North Korea had managed to set fire to half of the Western United States and kill 1 million people in the United States, you know that there would have been a policy response to that. And it would have been backed up by kind of the most fearsome arsenal of weaponry and the largest military alliance that we've seen in history. Of course, you know, climate change and wildfires and the COVID pandemic essentially did just that. But because of the fundamentally actorless nature of the threat, it's harder to mobilize or to catalyze mobilization of the kind that we saw, say, after Pearl Harbor, right? Or even after September 11th, to affect a whole scale and radical reshaping of our mindset around what constitutes national security, but also the kind of funding priorities and the kinds of investments that would be necessary to act on that reconceptualization. That's my perspective on that.
Well, thank you. Ellen?
Yeah, I want to add on that, just kind of a general comment on how those different policy issues are kind of linked, and to what extent knowledge that was known for a very long time on one issue doesn't pertain super well on another issue. I think when you think about climate and migration in particular, the reason it's so important to address those complexities that are known, I mean, it's been known for a long time that a lot of things go into migration decisions, is because of the way the migration topic has been framed in the climate change debate, where people have been coming at it in some cases with kind of intents to use migration as a way to raise awareness on the climate change issue in a place like Europe that has been very visible, where physical impacts of climate change were not necessarily extremely visible. And for a while, we could see in the general debate migration being used as, this is what climate change is going to look like here. We're going to see incoming migrants from other countries coming into Europe, perhaps as a way partly to raise awareness on climate change, but actually the consequences that we've seen so far hasn't been that much, you know, an increased action on climate change, but much more a closing of borders. So you see kind of different policy discourses across policy issues that don't make sense, perhaps if you look at them from just one angle, but start making sense if you look at the ranking through which people actually take action on policy. And I think that's why it's important to insist on those complexities across issues over and over, because the framing of one issue in another realm is actually not necessarily very constructive and often counterproductive.
That's great. That's great. All right. Well, we're about to have to wind up, but it would be inappropriate not to bring in what's happening in Ukraine, given that we're having a conversation about migration and conflict and insecurity. And obviously, the fire under the pressure cooker in that case is not climate change, it's Russian aggression. But we're seeing the biggest migration event in Europe since World War II as we speak. And I guess I'm just wondering in the last couple of minutes if anybody has any reflections on any ways in which what we're seeing relate to today's conversation.
So I can jump in on that. I guess I would say setting aside the disastrous consequences of the conflict for Ukraine, I am not particularly concerned that the refugee and displacement crisis that is occurring is going to lead to the types of conflicts that I was discussing earlier, and that's because the demographic and economic and kind of structural profile of countries that are most kind of at risk to migration related kind of group identity based kind of conflicts are simply not present in that part of the world. Now, if we we wound the clock back 100 years, right, we would be looking at a very different kind of picture. And I only highlight that because I think it's important to realize that sort of the regions of the world in which we see these dynamics operating are not sort of, they're not fixed in stone, right? That the idea that these identities are going to continue to be so effective as sources of mobilization is not necessarily the case moving forward. I think we should focus on the humanitarian disaster, and I think we should focus on mobilizing resources to meet the need. I do not think that the refugee crisis itself is something we need to be viewing through a security lens.
Terrific. All right. Well,
can I follow up with one question there for Cullen? You've mentioned two things which I think are really interesting, right? The forest fires and then the kind of perspective on Ukraine. For Ukraine, there's definitely a direct cause and effect, and the Biden administration did a fantastic job of demonstrating intention and culpability on the part of Russian aggression. With forest fires, it's a much more complex relationship between climate change and particular outcomes. And so the ability to clearly and distinctly understand causal mechanisms, I think, is a critical element here. How much do you or other of our speakers think that what was necessary is really to understand the basics and the interlinkages across kind of complex dynamics, as opposed to really just there's other hindrances to kind of large-scale organization to address the threats associated with climate change?
No, I'll just speak briefly on that. I mean, the attribution issue is very important here because there are lots of people who will gladly concede that weather patterns are affecting their crops or affecting their livelihoods, or that forest fires seem to be increasingly sort of frequent and indeed affecting areas that are right kind of the rural urban sort of interface here in Colorado, just 20 miles from my home. I think that the problem historically has been that it's difficult to sort of say that any one of those events was caused by climate change, right? Now, the science, I think, of attribution is getting much stronger here. Perhaps John or Helen would have some thoughts about the specifics of that.
I'm going to jump in here. I apologize, but we're sort of out of time, and I want to make sure we have one last minute to give you a couple of highlights. So apologies for that. Enormous thanks to John and Helen and Cullen for such a rich conversation, and to Peter for being willing to be put on the spot. So really interesting. All of this will be recorded, as we said. The link is in the chat. Coming up next on April 7th, which is actually World Health Day, we are enormously lucky to have Paul Pullman, who's the former head of Unilever and really sort of a global leader in thinking about how the private sector can promote planetary health. And he'll be alongside Rudiger Krech, who is the head of health promotion for the World Health Organization, which just released the Geneva Charter on Health Promotion, which is really sort of a strong statement of planetary health. And then Eva Zabi, who runs Business for Nature, which is a consortium of really the world's largest businesses that are advocating for a regulatory and policy platform that would allow businesses to sort of be doing the right things with respect to the great transition in planetary health. And so it will be a conversation about how the private sector can become a real catalyst in creating the deep structural shifts in how we live that will be necessary to achieve Planetary Health with Paul Pullman, Rudiger Kreck, and Eva Zabi. So hopefully you'll be able to join us for that. It's not going to be on a Wednesday. It's going to be on, I think it's a Thursday. It's April 7th, because that's World Health Day, and it will be co-sponsored by the World Federation of Public Health Associations as well as WHO. So we're looking forward to seeing some of you again. And with that, we'll draw it to a close at 2 o'clock. And thank you all so much for your talks and also for being here to listen to them.